Are we alone? Is one of the biggest questions humans ever asked. But instead of guessing, astronomers use an equation to estimate how many intelligent civilizations might be out there. It's called the Drake equation. Even though it looks scientific, it's just really a way to organize our uncertainties. In 1961, an astrophysicist, Frank Drake, wanted a structured way to think about our chances of other civilization in the Milky Way. So he wrote an equation with 7 factors, each representing a step needed for intelligent life to exist and communicate. The first 3 terms are the easy ones. These are the part we actually know or have some idea what the numbers are. But the last 4 terms we are not sure. So let's start with what are these terms. So the first term is the rate of formation of stars. So how many stars does the Milky Way produce each year? And the answer is this 1 to 3. Our galaxy is a star factory and it's been running for 30 billion years. The Pillar of Creation in the Eagle Nebula are perhaps the most famous star-forming structure ever imaged. The Pillars of Creation are towering columns of gas and dust that are incubated where the stars are slowly condensing out of the clouds. The James Webb Space Telescope gave us a stunning new look at them in 2022. In the picture, you see those bright red orbs scattered throughout the image are protostars. Stars that are caught in the act of being born. A dense pocket of gas within the pillar reaches a tipping point where the gravity overcomes the outward pressure of the surrounding material and collapses inward, and over the hundred of years grows hotter and dense enough for hydrogen to fuse to ignite a true star. And you see along the edges of the pillar, the wavy lines that look like flowing lava are ejected from stars still in the process of forming. These stars are only few 100,000 years old by cosmic standard and will continue forming for millions of years to come. The second term is the fraction of stars that have planets. Thanks to the Kepler mission, we know this number is at least 0.7, probably closer to 1. Almost every star has a planet. That was a guess in 1961, today is a fact. The chart in the picture shows 4,034 planet candidates discovered by Kepler mission as of June 2017. They plot each one by how long it takes to orbit its star and how large it compared to Earth. The dense blue cloud packed in the lower left corner reflects Kepler detection method, where planets that orbit closely and cross the star frequently were just easier to spot, meaning that the actual number of the worlds out there is almost certainly far greater than what is shown. With over 4,000 candidates from just one telescope staring at a small patch of sky, the takeaway is impossible to ignore. Planets are not rare exceptions, they are everywhere. And the third term is how many of those stars are habitable. So this habitable zone is basically it's not too hot or not too cold. Current estimates say it's about 0.2 to 0.5 per system. The current estimates say it's 0.2 to 0.5 per system. Not every star gets one, but there are billion of stars, so billion of chances. The chart shows known exoplanet candidates, but how much the starlight they receive compared to Earth and how hot their host star is. With the shaded region in the marking, the habitable zone where the liquid water could exist on the surface. The conservative zone between the yellow and the blue line is where the scientists are more confident, while the optimistic zone stretches further in both directions, including edge cases. Much like how Venus and Mars sit just outside our solar system sweet spot, the exoplanets like Proxima Centauri b, TRAPPIST-1 planets right in the critical band, making them the most watched target in search for life. Now let's go back to the part where we're guessing. These are the last 4 terms. Here what equations stop being astronomy, start being philosophy. So the 4th term is the fraction where the life appears. We have exactly one example, Earth. And life here showed up almost immediately within a few 100 million years. That's either mean the life is easy and the universe is teeming with it, or we got extraordinarily lucky. One data point can't really tell you much. The next term is the fraction that develop intelligence. This is a big filter. Earth had living things for 3.5 billion years before anything bothered to think. Most species that ever lived were perfectly content being bacteria. Intelligence might be fluke, not a destination. The second last term is a fraction that built detectable technology. Humans did it, dolphins didn't. There might be brilliant civilization out there that never felt the need to broadcast. And the last term is the life of communicating civilization. This is the term that changes everything. 100 years, a million. If civilization tend to destroy themselves shortly after discovering nuclear physics, and we don't know yet, if they don't, maybe we find out soon, then the galaxy could be full of dead. If the last million of years, we should have seen neighbors everywhere. So how many civilizations are out there? Plug in the pessimistic value, you get about 20 civilizations in the entire Milky Way. And plug in the optimistic value, you get 50 million. The first term are basically kind of solved, we have a good idea, but the last 4 terms, we are not even close to answering those. The Drake equation doesn't tell you how many civilizations are out there. It tells you what we need to know to find out, and how little we actually have. Thanks for watching, and if you want to support my channel, consider liking, share and subscribing. It genuinely helps. If you are able to pledge, that really makes a difference. I will see you in the next one.